Okay, so welcome. This was this bonus probability task that I said. Okay, so we need to read this carefully because it's slightly different to the problems we've seen in the book. So we need to make sure that we're interpreting it carefully. Okay, so we're told that a family has two children, and we're told what we have to find. And that is, we have to find the probability that both children are girls. Okay. However, this calculation, it's based on this given information, and that is that at least one of the two children is a girl who was born in winter. Okay. And as we would expect, I mean, this is stated here for completeness, but this is, I guess, what we would assume anyway if the question didn't say it. So we're assuming that births during any one of the four seasons are equally likely, and that gender is independent of season. That means that that boy and girl is equally likely, and that it's equally likely in all four seasons. Okay, right. So, so I think that the clearest way to think about this is to begin by just thinking, well, what would be the situation if we did not know this extra information? Okay, and to think about that, and then to think, well, how do we need to modify things to take account of the given information? Okay, so I'm going to present a solution that does it in that way. So here I'm letting B subscript I, G subscript I be outcomes that a boy or girl is born in season I. So I'm basically using G1 for a girl that was born in winter, G2 for a girl that was born in spring, and G3 a girl born in summer, G4 a girl born in autumn, and then the same for the boys, B1, B2, B3, B4. And there are two children, so I'm saying that a priori, that means without using any additional information, there are 8 equally likely outcomes for the birth of each child. That there are two children, and each one of them could be a girl or a boy with equal probability. And for each gender, then the seasons are equally likely. Okay. So if we didn't have any additional information, we would have a sample space with 64 equally likely outcomes, which we can show on this 8 by 8 grid here. Okay. So now let's think how the additional information affects our reasoning. Okay. So it's given that at least one child is a girl who was born in winter. Okay. So with this given information, then we don't have 64 outcomes anymore. Okay, so you might want to just pause the film a moment and just think, how many outcomes do we have if we take into account this information? I'll just wait. 3, 2, 1. Okay, so the answer is that now there are 15 equally likely outcomes, because a girl who was born in winter, we're denoting that by G1. So that means that we know at least one of the children was a girl born in winter. So that means we either have to be in this column here, where one of the girls is a girl born in winter, and the other could be any of the other 8 possibilities. So we must be either in this column here or in this row. Okay, because it could be the other child that is a girl born in winter. Okay, and they could both be as well. So we could also be in this square. Okay, so you see here that in this row there's 8 outcomes, and then we've already counted that one, so there's 7 more here. So 15 possible outcomes. Okay, and then we have to say, then we have to calculate, well, what is the probability that we're finding? Okay, well, we're finding the probability that both children are girls. Okay, so now we've found that there's 15 equally likely outcomes given all the information, and now we can find how many of those outcomes are such that both children are girls. So if we look at this, then the ones where both children are girls, that is when we're here, these 4 outcomes, or here. Okay, so the first half of this row are in the first half of this column. So we have 4 outcomes here, and then 3 more here. So the answer is 7. Okay, so that means that the correct answer to this problem is 7/15. Okay, so 7/15. Okay, so thanks for watching.